Well, hi there, boys and girls. Today we're going to take a look at how to integrate things that involve natural logs. And since we know the derivative of natural log of u is 1 over u times du dx, if we get into any situation where we have 1 over u times du, then it's going to integrate into the natural log, because integration is the inverse of differentiation. So let's get started here. I've got the integral of 2 over x, and I'm going to pull that 2 out in front. And I'm just going to make this 2 times the integral of 1 over x dx. And since we know the derivative of natural log of x is 1 over x, that means that the integral of 1 over x will be natural log. Now we have to put, if we introduce a natural log function, we are going to have to put absolute values around it, because the natural log, remember the domain for natural log is all positive numbers. So we're going to put absolute value around our natural log argument. Alright, so let's take a look at just doing it on a definite integral here. I already know what this antiderivative is 2 natural log of x. So we're going to do a definite integral from 1 to e. This is going to have us remember what natural log of e and natural log of 1 are. That's very important to remember. So we're going to do the antiderivative, which we already know is 2 natural log of x. And we're going to go from 1 to e. And so the FTC says we plug the e in first. And e is positive, so I don't need to put absolute value on it, minus, then we plug in the bottom number, and 1 is also positive, so I don't need the absolute value bracket, and then we can evaluate this. The natural log of e is 1. 1 times 2 is 2. The natural log of 1 is 0, because the natural log graph crosses the x-axis at 1, 0. So the natural log of 1 is 0. So this answer is just 2. Let's take a look at one where we have to do some u substitution to create natural log of u, a natural log of u antiderivative. I'm going to let u equal the bottom of my integral. If I ever have a fraction, I'm going to check this first, because this is a fairly easy antiderivative. If you ever have a fraction, check and see, is it u prime over u, or is it 1 over u times du? If it is, it's going to be a natural log integral. So if I let u equal 2x minus 1, then my du is equal to 2 dx. And what I have left over is a 1 dx. So I'm going to divide both sides by 2. This should look familiar. 1/2 du equals dx. So I can turn this integral into the integral of 1 over u times 1/2 du. And look what we've made. We've made our natural log integral. So this answer is 1/2 natural log of the absolute value of u. But my u was 2x minus 1. Some of you learned the lesson the hard way, that you had to back substitute from your test. So that would be your answer. Another thing, you could rewrite this, just so you know, this could be natural log of the square root of 2x minus 1. Remember that rule about this power here? This 1/2 can come up here as a power on the 2x minus 1. And the AP test does like to manipulate those and check you on that. So that's always good to practice. This looks pretty complicated, but if you see a fraction, especially if the denominator is 1 degree larger than the numerator, check and see, is it u prime over u? So let's let u equal x cubed plus x. Then du would equal 3x squared plus 1 dx. And man, that's pretty. Look at that. 3x squared plus 1 dx is exactly what I have up there. So when I do my u substitution, I get the integral of du over u. By the way, that's the same thing as the integral of 1 over u times du. You can write those in either form. I actually prefer this form right here. If you have a derivative on top of a function, that is going to be a natural log integral all the time. So this is going to be the natural log of the absolute value of u, where u was x cubed plus x. And then we'll put our plus c so I don't get a minus 1 on my test. Let's take a look at a definite integral. Now, I have a fraction here, however, the denominator is not 1 degree larger than the numerator. The top is, if you let u equal x, du dx is 1. And so we've got way too much stuff up here. If you have parentheses and a power on that parentheses, you should probably start by letting u equal what is inside that parentheses. It's a really good start. Not saying it always works, but it's a good start. You let u equal 1 plus natural log of x, so du is going to equal 1 over x dx. The derivative of 1, remember, of course, is 0. The derivative of natural log of x is 1 over x. That's exactly what I have left over. The x is on the bottom, the dx is out to the side. This is equal to du. So we're going to go ahead and change our bounds as well. We're going from 1 to e. So when x equals 1, u equals 1 plus the natural log of 1. And that's going to be 1 because natural log of 1 is 0. And when x equals e, u is going to equal 1 plus the natural log of e. The natural log of e is 1. 1 plus 1 is 2. So we completely turn this integral into the integral from 1 to 2 of u cubed. The u was 1 plus natural log of x, and the 1 over x dx was my du. And we turn it into an integral that's not even a natural log integral. So I'm going to add 1 to my exponent and divide by that. So I'm going to get u to the 4th over 4. And we're going to evaluate this between the bounds of 1 and 2. So I'm going to plug my 2 in first. That's going to be 16/4 minus, plug in your 1, 1/4. And that they have the same denominator, so I guess I can go ahead and simplify that to 15/4, although we all know that's not necessary. Another example, you have a fraction, but the denominator is not 1 degree larger than the numerator. So this might not be u prime over u. Saying I've got something in parentheses to a power, so you should probably try to let u equal whatever is in parentheses. U equals the natural log of x. So du is going to equal 1 over x dx. And that's nice because that's exactly what I have left over. So we're going to go ahead and continue to change our bounds. So when x equals e, u is going to equal the natural log of e, which we know is 1. And when x equals e squared, u is going to equal, I'm going to go ahead and write this one out, the natural log of e squared. The easiest way to do this problem is to bring the 2 down in front of the natural log. And the natural log of e is just 1, so the natural log of e squared works out to be 2. So u equals 2. So this integral will be the integral from 1 to 2 of u to the 4th du. So this is going to be u to the 5th over 5 evaluated between 1 and 2. So this is going to be 32/5 minus 1/5, or 31/5. Alright, so let's take a look at one where we have a fraction, we don't have something in parentheses raised to the power, and it's a little backwards. The denominator is actually 1 degree smaller than the numerator. If that ever happens, you are going to need to divide this fraction out using algebra before you integrate. So what you're going to do is you're going to have to do x squared minus 5 divided by x plus 2. You can do this with synthetic division, but well, that should be a minus 5, so we're just going to scratch that out. I'm going to use long division so you can remember this. X squared minus 5 divided by x minus 2. Now we're going to need a placeholder in here, so I'm going to call this actually x squared minus 0x, I'll put plus 0x, and then minus 5. There's going to be some groans when you have to do this, but unfortunately I have to teach you how to deal with all these situations. So if the top is 1 degree larger or even bigger than that, we need to divide it out. So with long division, the first thing we need to ask ourselves is, self, what times x gives us x squared? And that answer would be x. So we put that on top and then we back distribute. X times x is x squared. X times negative 2 is minus 2x. You see why we needed that placeholder now? We've got to have something to add this negative 2x to. The next step is to subtract. X squared minus x squared, of course, is 0. 0x minus negative 2x is a positive 2x. Alright. Whoa, I made a mistake here, it looks like, because I'm supposed to be dividing by x plus 2. I just noticed that, so please let's back up and accept my apologies. That's supposed to be an x plus 2. And so let's see if we can change this. My apologies here. So x times x is x squared. X times positive 2. This should be a positive 2x. Mr. G. There we go again. Rookie mistake. Alright, so that means that I actually have a negative 2x left over. And then the next thing you do is you bring down your minus 5. And then the last thing we have to do is ask ourselves, self, what times x gives me negative 2x? And that should be minus 2. So negative 2 times x is negative 2x, and negative 2 times 2 is negative 4. Then we're going to subtract. Okay, those cancel, and negative 5 plus 4 is a negative 1, and what you do with your remainder is you write it as 1 over the divisor. And I know that's not fun, but that's how you're going to have to deal with this. And so we're going to turn this into the integral from 0 to 3 of x minus 2 minus 1 over x plus 2 dx. We have changed our integral by actually dividing. Now this is not so bad. I can just integrate through this, and I can get that I'm going to do 1/2 x squared minus 2x minus, this is a u prime over u. If you let u equal x plus 2, the derivative of that is 1. So that's just 1 over x plus 2. That's u prime over u. So this is the natural log of the absolute value of x plus 2. And we're going to evaluate this from 0 to 3. And I'm out of room. And I've already made a rookie mistake on this one. So let's pretend that I plugged in the 3 for all the x's and then plugged in the 0 for all the x's and subtracted them. So I apologize that I'm out of room. So you can just write here that we pretended to finish. I can't even write the word finish there. All right, so there's four trig integrals that we have to learn, and they're listed right here, and I want to show you why they're true first of all. It says the integral of tangent of u is negative natural log of cosine of u plus c, and I want to show you why that's true. The integral of tangent you could think about as the integral of sine of x over cosine x. Do you remember that big long formula chart in pre-cal that had all those identities on it? Well, tangent is sine over cosine. It's a fraction, and on top of that, it is almost u prime over u. What's the derivative of cosine? Well, it's negative sine. So this is actually a negative. If you put a negative on top and the negative outside, that's why it turns out to be the negative natural log of the absolute value of cosine.
Are we supposed to answer that?
Yeah, we are, and Jordan is here helping me. So let's fill this in. I got flustered up here and didn't even finish this. So what did we do? We're going to write you must divide. I want to have complete notes here. I'm glad I have her here to help me. All right, so hopefully that makes sense here for why the integral of tangent is negative natural log of cosine, because tangent is a fraction and it's almost u prime over u. So that's why it works out to be a natural log. Now secant is really, this one is funny. The reason secant works out to be natural log of secant plus tangent is because if you miraculously multiply the top and bottom by secant x plus tangent x, this is one of those weird proofs that we just do something weird like multiply by a clever form of 1, and that clever form of 1 is like secant x plus tangent x. If you multiply this together, you get secant squared x plus secant x tangent x, all divided by secant x plus tangent x. And you might think, why in the world would somebody do something like that? Because we took an integral of secant x and we turned it into what looks like almost impossible. That looks tough. But maybe this is u prime over u. If you let u equal secant x plus tangent x, what is du? What is u prime? U prime would be the derivative of this, and the derivative of secant is, do you know what that is? It's secant x tangent x. And the derivative of tangent is secant squared. So we actually have u prime over u. That top is just the derivative of the bottom. So the answer to that is the natural log of the bottom. So that's why it works out to be the natural log of the absolute value of secant x plus tan x. And I know you're thinking, wow, another thing to learn, but sometimes it's not all rainbows and unicorns up in this place. All right, the last one we're just going to actually answer, integral of tangent of 3x. So I'm going to let my u be what's in parentheses there. U is going to equal 3x. So my du is going to equal 3 dx. Now I don't have a 3 here, so I'm just going to solve this for dx. So I'm going to have 1/3 du is equal to dx. So I'm going to turn this integral into the integral of tangent of u times 1/3 du. And so I can use my formula. The integral of tangent of u is negative natural log of the cosine of u. So my answer to this, I'm going to scoot it down here to the bottom, is going to be negative 1/3 natural log of the absolute value of cosine of u, and u was 3x plus c. All right, so I guess that's enough for now, and I will see you guys tomorrow.